diagram shows part of a curve and a point 6, 5 lying on the curve. The line PQ intersects the x-axis at 8, 0. Show that PQ is normal to the curve. Okay. If PQ is normal, that means the tangent at P will have a gradient that is negative reciprocal to the gradient of PQ. So we first have to find gradient of PQ, which is the gradient of normal. Let's see that what do we get? Or this is gradient of PQ. Let's not call it normal first because we don't know it's normal or not yet, or we have to prove that it's normal. So gradient of PQ is going to be y2 minus y1 over x2 minus x1. That comes out to be minus 5 over 2. Okay. Now, if this gradient is minus 5 over 2, and you can show that the gradient of tangent is 2 over 5, that means that there's a 90-degree relationship between them. That means the line PQ is normal. Okay. Now we find gradient of tangent. So we have to find MT. For that, we will have to derivate the given curve dy by dx of this. Half comes down, power gets reduced by 1, so negative half. And also you have to multiply the derivative of 1 plus 4x outside. That is just 4, so times 4. So we're getting 2 times 1 plus 4x power negative half. In this, we substitute x is equals to 6 and get the value of the gradient. So let's see, 1 plus 4 times 6 is 25. Power minus half is 1 upon 5. So we are getting 2 over 5. So now you write since minus 5 over 2 times, sorry, this was 5 upon 2. Sorry, this was what it came out to be 2 upon 5. Okay. Times 2 upon 5 equals negative 1. Hence, PQ is normal equation of the, hence PQ is the normal to the curve. Since we know that tangent and normals are perpendicular to each other, and if two lines are perpendicular, then the product of their gradient is negative 1. Okay. Part 1 is done. Okay. Find showing all necessary working, the exact volume of revolution obtained when the shaded region is rotated 360 degree about the x-axis. Okay, so first let's rotate this curve 360 degree about the x-axis. So the formula for that is pi, lower and upper limit of x, which are 0 to 6, function, which is 1 plus 4x power half squared. Remember to square it, dx. So we have pi 0 to 6. When we square the function, the half and the 2 gets cancelled. We just have 1 plus 4x dx. This is going to be the volume for this region only. Okay. You're going to get a whole 3D volume by applying this integration formula. Okay, now we also need volume of the other side for this line. Notice that when this revolves around the x-axis, this becomes a cone. So instead of finding equation of PQ and then integrating it between 6 and 8, what I'm going to do is use volume or formula for volume of a cone. And this length is going to be the radius of the cone, which is 6 units. So the radius is 6 units, and this length is going to be the height of the cone, which is, sorry, the radius was 5. That's a mistake. This is going to be the radius 5. And this length is going to be the difference of the x values 6 and 8, which is 2. So I'm going to add the volume of cone to the result of the integration, which is going to be 1/3 pi r square h. Okay, now let's integrate the curve. Okay, we get 25 times 2 is 50. This would be 50 by 3 pi. Okay, now let's integrate the curve. That would be x plus 4x square upon 2, and the limits are 6, 0, and outside there's also a pi. Let's simplify this and write 2 instead. Okay. Now substitute 6. Write your result, a negative sign, substitute 0. So when you substitute 0, you'll get a 0. And when you substitute 6, we're getting 78. Okay, so 78 pi plus 50 by 3 pi is 284 upon 3 pi, which is the final answer.